Dear viewers, greetings. Now I am present about infrared spectrophotometer. An overview. Infrared spectroscopy is the study of absorption of IR radiation which result in the vibrational transition. It is also mainly used in determining the functional group. Now we are going to see introduction, principle, types of infrared spectroscopy and instrumentation of spectroscopy. Introduction. Vibrational spectroscopy is also known as infrared spectroscopy. It is an analytical method that make use of molecules vibrational transition. It is among the most popular and extensively applied spectroscopy methods. An infrared spectrometer, also known as spectrophotometer, it is used to the process of infrared spectroscopy to generate an infrared spectrum. This is the picture to see this process how to run. The first one is IR source. The system begins with the infrared radiation source. This emit infrared light which is necessary to analyze the molecular vibration in the sample. And second one is monochromatic system. This system filter and narrow down the IR radiation to a specific wavelength for analysis. And third one is reference and sample. The higher beam is split into two parts. One beam goes through the reference and another beam goes through the sample that is being analyzed. And fourth one is splitter. The beam splitter divide the IR radiation into two beams, one for the reference and another one for the sample. And fifth one is detector. After passing through the sample and reference, the beam are directed to the detector. The detector records the intensity of the radiation that passed through the sample and the reference. And sixth one is readout. The final data is sent to the readout device such as a computer display or printer. The resulting graph shows how much of the IR light was observed at the different wavelengths, producing an IR spectrum that can be used to identify and analyze the sample. Then we are going to see a principle of IR spectroscopy. Examination of a molecule interaction with the infrared light, the wavelength range of the infrared area that is most powerful for the analysis of organic substance is between the 2500 to 16,000 nanometer. Vibrational stimulation of covalently bond atoms or groups are attached. Now, principle of IR spectroscopy. As a result, infrared spectroscopy light will be observed by almost all organic molecules. In theory, infrared spectrometer are capable to other comparator spectrometer. A plot of observed infrared intensity against the light wavelength is employed. The functional group can also identify by using an infrared spectroscopy to analyze the vibration of the atom. Stronger bondings and light atoms will often vibrate at a high stretching frequency or wavelength. Then, types of infrared spectroscopy. In transmission spectroscopy, the amount of light that passes through the measured by sandwiching the sample between the infrared source and detector. And second one is attenuated total reflectance. This sample method analyzes solid or liquid sample without requiring significant preparation by having the infrared beam pass through the crystal that is in the touch with the sample. Next, instrumentation of infrared spectroscopy. This is the main sources present in infrared spectrometer, that is radiation source, sample cells and sample of substance, monochromators, detectors, recorders. And first we are going to see IR radiation source. As source of radiant sources that generate infrared radiation must be constant, strong, enough to be detected and cover the required wavelength in order to form an IR device to function. Various sources of infrared radiation such as near-nest globe, incandescent lamps, mercury arc, tungsten lamp, global source and last one is nichrome wire. Then second one is sampling cells and sampling of substance. Infrared spectroscopy is used to detection of solid, liquid and gas samples. First one is solid sample. Various techniques are used for preparing solid sample such as pressed pellets technique, solid reddening solution, solid films, melt technique, etc. Second one is liquid. Sample can be held using a liquid sample, cell made of alkali halides. Aqueous solution cannot be used as will dissolve alkali halides. Only organic solvent like chloroform can be used in the liquid form. And third one is gas form. Gas is the sampling of gas is similar to the sampling of liquids. Then we are going to see monochromatas. Prisms, gratings and filters are a few different kind of monochromatas. One can make prisms out of calcium iodine, sodium chloride or potassium bromide. Alkali halides are used to make diffraction gratings and lithium fluoride is used to make filters. Detectors. It is used to measure the intensity of unabsorbed infrared radiation. Detectors like thermocouples, bolometers, thermometers, pyroelectric detectors are used. And last one is recorders. It is used to record the IR spectrum and show the result. Applications of infrared IR spectroscopy. First one is it is used for the protein characterization, used to detect nanoscale semiconductor, used for space exploration, analysis of gaseous, liquid and solid samples, and used for identification of compounds and used for qualitative analysis of various samples. In organic chemistry, it is used to identification of functional groups in organic compound. And in material science, it is the characterization of polymers and materials. In pharmaceutical, it is analyzing the active ingredients. In the environmental science, detecting pollutants and understanding atmospheric composition. Then we are going to see advantages for infrared spectroscopy. First one is non-destructive. It is used to minimal the sample preparation and no destruction of the sample. And second one is quick analysis, fast result and relatively straightforward interpretations and speed up the reactions. And last one is limitations for infrared spectroscopy. First one is complex measures. Overlapping peaking can make analysis of complex sample challenging. Sample preparation. Some samples may require specific preparation to obtain accelerate result. Thank you.